Hi guys. I just need to remind you that format of our session is a tech talk. So don't hesitate to stop me in any slide at any word and ask any question you want to discuss. It's not a conference session. When I go into talk hour or more and only 5 minutes after that I'm going for questions. So stop me at any moment. Okay? I have no introduction slide, unfortunately, but as you already heard, I have been with the PAM for more than 12 years already. I'm working at Java Competency Center. There is a kind of organization which just work on building a community inside of a PAM, specifying different set of skills which each employee need to follow and trying to know. And it's not only about that. We also help them some internal projects, external projects, doing some architecture review, working on the pre-sales and architecture design, of course. It's briefly about me. So as you can see, our talk, today's talk, about microservices and not about implementation, but mostly about architecture patterns and about overview. What is it and how we can deal with it. Today's agenda, we discussed briefly microservices, and most of the time we are spending discussing and talking about patterns which microservices architecture need to follow. And one of the tricky questions about API version and how we can organize versions and organize contracts in our microservices in order to integrate them smoothly. First questions regarding microservices, why do we need it at all? Actually, it all depends. Some application need it, some application do not need it at all. There is a one of the Gartner's report which says that some application need to go fast, another application need to go less fast than previous. So it's a normal situation when we have highly loaded applications and highly loaded products which really need to reflect this load somewhere in some kind of. But there is an application which do not require it at all. And it's better to stay at old approach, maybe legacy one, and do not introduce such a complexity which brings with microservices. But today we are talking about microservices and the kind of application which really requires microservices and such kind of complexity which it brings with this approach. Actually, we can compare previous approach which we all used before. I'm pretty sure that everyone writes and was involved in a project which was built in the Monolith approach, but maybe some of you already tried by yourself, maybe it's your pet project, maybe it's your current project, microservices. By the way, who already tried to build something which can be called as a microservices? Few hands. With a real project or pet projects? Boss? What? Production projects. That's nice. I expect lots of questions from you, maybe some recommendation. Okay, we can compare Monolith and microservices. As you know, Monolith, it's always, in most cases, is a complex code base. I'm not counting project with 10,000, 20,000 of code. It's hard to say that it's real monolith. It's small project from my experience. But I'm talking about project with 500,000 and million or 2 million lines of code. It's a really big projects with a lot of teams involved in the development. I worked on projects with 5, 10 teams, which are working not using Scrum, but they try to. Sometimes they worked using waterfall, and they're working in a code base with lots of dependencies, lots of code. It really became a nightmare to integrate all team together, to integrate some new people into the process, just because to know all this code base, all these functions which already implemented really hard for newcomers. From another hand, we have a microservices, which a bit simpler, just because we are trying to split our functionality to some bounded context with a less set of functionalities that all monoliths had. Also, already known issue of every monolith that it's hard to maintain modularity inside of it. Every project manager, every technical lead, every architect trying to design software and trying to push the team to use modularity. But it sounds easy, but it's very hard to make it in practice. Even if your software will be designed very well, even if it will be split into modules and some logical boundaries, it always will be a guy who make his own sort on this and try to use one method from another, one layer. For example, at UI side, try to use data access layer and something like that. And it always became a nightmare to manage this code. It will be, and this adds a lot of complexity into the code. And as I said previously, it will be a nightmare for newcomers to recognize where is these boundaries, where is these modules, where is these layers. And all newcomers looking into this, trying to copy this approach to his functionality, which he will be implemented, and the mess became much bigger during the time. At microservices, we of course can make this complexity inside of code, but it's much easier to avoid this, just because your code base is not such big as monolith application, and such a boundaries exist not only on a logical layer, but on a physical layer between different services. Another point which we can compare is change cycles and release cycles, which are really toughly coupled in a monolith application. Let's imagine we have a team of, let's imagine we have a project with 5 or more teams, and they are working on some release at its usual plan. And one of the team found a bug, maybe not ready with the functionality at the end of release cycle. And all other teams which already done with their changes, with the functionality, just will wait this one exact team while they're fixing this bug, while they're trying to develop their functionality which are going to be released. And in this case, they're all coupled in a one monolith, in a one release cycle, and nobody can release their changes while other teams not ready. In case of microservices, all teams work independently, and in case the changes are ready, they just can push it to production in any time without waiting anybody. And after that, all teams can utilize these changes, just this new functionality, new methods, new API, something else. This situation is more complexity or more flexibility to development, and allow us to bring new changes to market much faster. Another point, and which is now one of the important points, is inefficient scaling for monoliths, and from other hand, efficient scaling from microservices. It's usual situation when part of the monolith, maybe it's one from 10 or 15 modules, much loaded than others. And in this case, all monoliths will be copied to new node, and consumes much more resources than needed in current situation. In case of microservices, let's imagine you have 10 modules, and one of them are overloaded on some, or expected to be loaded somewhere. In this case, we will scale only this one module. And our resources will be consumed much more efficiently, and our customers spend less money than expected in case of monoliths. I've already said regarding onboarding for newcomers and adoption of newcomers as a project. Of course, it's much easier to understand 10, 20,000 of code than 1 million lines of code. Another point that it's really hard to scale development team in a monolith. As I said, there are lots of reasons for this. One of them, this new team will be coupled to their release cycle, I mean monolith release cycle, and it's hard to separate responsibility of this team inside of code, just because there will always be some shared libraries, shared services, some shared code, which all teams need to make changes in, and it adds a lot of complexity in the communication in a development cycle. In case of microservices, there is not such a dependency to other teams. You can develop your own microservice without any dependencies to other teams, and inside of your code base. And last but not least point regarding microservices, you have no technology lock at all. There is a usual situation when monoliths developing through the years, 5, 10 years, it's usual situation. And I think you have in your experience such a application which developed on the technologies which was chosen 5 or 10 years ago. It could be maybe Struts 1, it could be kind of EGB, Java 5, Java 6 at least, maybe some GSF. And of course, technology going forward, and there are lots of technologies which you can use right now, which are much more efficient and give you a way to develop your software, your functionality much faster than 10 years ago. So this is briefly about comparison. Maybe any questions? Nope. Okay, so let's summarize a bit which values microservices bring to us. One of the values is a continuous delivery principles, which each microservices need to follow. Just because in case you will deliver your services manually, not in an automatic way, it will be, I can't say it will be complex, it will be complex a lot. Just because in case you are delivering your monolith application, it's on one binary file, so you can always manually upload it somewhere and distribute across your cluster. In the case of microservices, it could be 10, 50, maybe hundreds of binaries. It will be really hard to deliver them all manually. You need to specify your automatic continuous deployment, continuous delivery pipeline, and utilize them efficiently. Of course, it's hard to make it, but it's only one-time effort at the very beginning. But after that, you can utilize this pipeline to all new services. You need to follow fine-grained domain capabilities. All books say that you need to build your microservices around business capabilities. Maybe you heard about domain-driven design, maybe you read books regarding this. And this book said that we need to build, actually they said about domain-driven design, but these principles matched to microservice architecture very well. You need to build your functionality around business capabilities. And it doesn't mean that, for example, we have, I don't know, some employee entity inside of company, maybe some customer entity inside of some customer domain. It doesn't mean that microservices will be called as a customer, and it will be one binary. It's not like this. It will be an aggregated layer, which aggregate underneath of this layer exact microservices, which in terms of domain-driven design called building blocks. Another point and another value of microservices, as I already said, is autonomy of a team and autonomy in a responsibility in the technologies they're going to choose, in the release cycle they're going to choose, in everything. You do not need to confirm all your decisions with somewhere else, with some project manager, maybe with some delivery manager like it already done in Monolith, with some architecture board, maybe if there are any in a project. You can choose your technologies and your process inside your team as you wish. Process just need to reflect your needs, and you can choose such ones which are better work for you. I've already said regarding release cycle and independent scaling, it's one of the values, of course. And another value is system resilience. It's a very nice point, and there is a story at Netflix which was one of the drivers for moving them to microservices, when one of the engineers committed a code, and this code broke whole service for a few days. And whole Netflix services was out of the service for a few days. And after that, they decided that they need to change anything, and they decided to go to microservices and migrate to microservices. It's always an issue when in a monolith architecture, when whole application consuming memory, consuming resources, in case of some heavy and long-running transactions, maybe some batch updates and something else. And these issues affects all other functionality, affects user experience, and it's usual situation for monoliths. In case of microservices, and if one service go out of service, your whole system will become healthy and will work, and maybe you lose some functionality, but all other and most of other functionality will work and behave as expected. And last value, technology variation, you can use any. You can use any persistent which really reflect your needs. It could be a NoSQL, it could be a relation database, it could be graph database, whatever. So this is regarding values. Maybe some questions? Nobody want to argue regarding microservices and monoliths? Nope. Actually, in Minsk, we were spending maybe 40 minutes on these few slides, arguing each other. Okay. One more comparison. We can compare values of microservices and complexity which this brings to us in our development. One is the value, as I said, team autonomy, but it brings us lots of complexity in communication between teams. We're all people, and we all wanted to express our own opinion, but and in this case we need to communicate to other teams and prioritize our changes in their backlog, maybe if they depends. I mean, if they need to utilize our functionality which we are developing more efficiently than in a way of monolith, just because in a monolith you have one single backlog for each team, and this backlog have a priority inside of release, and you can just follow this backlog and implementing task by task. In case of microservices, you need to have some kind of cross-team communication regarding this backlog synchronization, so each team can expect some changes from another team in a more open way. So you can always know when change which your depends will be available in an API from other service. From one side we have time to market, which is really less than in case of monolith, but from another hand, as I said, we need to highly rely on a continuous deployment and continuous delivery. It's a very complicated process. Actually, from my experience, I didn't see it in ideal way in any project, but it's one of the questions, it's one of the priority which we need to follow in our future life. Just because everything changed, and continuous deployment and continuous delivery will be one of our next challenges we need to meet in our work, in our experience, and in our everyday life. Actually, it's a very wide question, just because everyone expected to see some DevOps guy in a team, maybe in a separate team, which always come to the project and solve the problems with environment, with deployment cycles, and so on. But from my expectation and from my opinion, this DevOps, it's not only about a special position and special guys. It's about a culture inside of team. There is a opinion that if you write this code, then you need to deliver this code. Your team need to deliver this code. I try to follow this opinion in my project, in my teams. And I just need to say that all developers need to know, need to be aware how to deliver this code and what pipelines they need to build in order to deliver these services to production. They don't need to call this DevOps guy and ask him how we can deploy our binary, how it will be distributed across environment. Just because without this understanding, you will not understand all microservice architecture at all, how they work and how they interact with each other. Okay, next value is efficient scaling and about everything about scaling, but from other hand is a fault tolerance, which brings complexity in a way how to manage it. In case one service will be unavailable or will be overloaded and trying to respond slowly, we need to know and we need to have a strategy how to behave in this situation. So all of this need to be developed and need to be specified before you're going to develop the service and to utilize some service. For example, each service needs to specify kind of SLA agreement, in what time they will respond to you, and what load this service can handle. So in case this service tried to respond slowly and response taken much longer than you expected, you need to know how to behave in this way. Maybe you need to take some cache results and skip these queries to this slow service. Maybe you need to stop asking him at all for some period of time, just because the service is overloaded and you can expect that all other requests will be much slower. So this kind of fault tolerance strategy need to be defined for every service. Another value is a componentization and modularity of our services, but this brings a complexity of versioning. Now, for example, you have some API with some version, with some attributes inside, and you need to know how to behave and how other services your consumers need to behave in order you create new methods, in order you add new attribute. But even if you remove some attribute or rename this attribute. And of course, technology variation, it's a common term, and some guys already arguing that you will have a zoo of technologies, but actually it's hard to imagine that you will have PHP, Python, maybe Node.js, Java, and .NET inside of one corporate landscape, but you can bridge that it could be Java and .NET at least. And from my understanding, it's absolutely normal. There are lots of enterprise having these technologies inside of corporate landscape for some reason, maybe some acquisition or something like that. But this technology variation gives us an flexibility. So team developing their services on some other technologies can continue to develop these services using these technologies, but we just can aggregate response from these services from some layer and make them available to maybe to users or maybe to other services. Okay. Maybe you have some questions. Yeah? Question? Only one? So the question is how to integrate this team inside of one. Okay. Okay. So the question is how to update all other teams about changes in the production and so on. Actually, good question, and lots of talk regarding it. There are a few approaches you can utilize, and one of them maybe not best, but which, as I know, Netflix already used. All teams provides a special client for these services. And other services can use this client, maybe it will be Java client, only using Java calls. Not remote API calls, but Java calls. So in this case, they quite smoothly and quite transparently integrates with other service, just using this one jar. But this approach have a pitfall, of course. Some guys call it distributed monolith, just because using this client library, you couple all other services, all other consumers to your service. And they highly depends on this client library. But Netflix using it. They're even going forward, they're moving to this client library some logic of these services. For example, yeah, hard to believe it, but anyway, they're using kind of caching in these libraries in order to make communication to API more efficient. They're using some circuit breakers inside and so on, but as I said, some guys, even inside of Netflix, call this approach as a distributed monolith. And I personally do not like it. It's better when team release their functionality and release this functionality with appropriate documentation. Having this documentation, you know how to utilize these services, how to utilize this API, and so on. So the idea is to have correct documentation and maybe somewhere shared backlog, and so other services will know when to expect new functionality available. Yeah.
Do we get a definition of what microservice exactly means? What microservice exactly means? Is it REST API? Is it some other kind of?
Nope, it's not only about REST API. It could be message-driven API. So of course, you can communicate each other using message bus. So it's not only about REST and HTTP calls. The idea is to have separate services, completely isolated from others.
So everything that communicates message-driven or event-driven?
Yeah.
Called a microservice?
Nope.
Not exactly.
Nope. I will come back in the patterns. I will describe it inside of patterns in this microservice part, which we can call it microservice. So I will, maybe it's time right now. So what exactly we can call it microservice? As I said, this service and this kind of functionality need to follow all these values which we discussed previously. One of them is an absolutely independent release cycle, independent development, and independent code base. This will add us a lot of agility. We can release our functionality much faster without any dependency to other teams, only in case you expected some functionality, for example, from sales context already done, and this functionality you need to utilize in a support context, but it's okay. You can implement it somewhere later, but it's not stopping you in a development at all. You can implement new features, I mean in support context, in case some functionality in sales context still not ready. So the idea is to have isolated context. And as I said, and as domain-driven design said, you need to have a context with exact boundaries. And this sales context, it's not a microservice. It's a context, but opportunity, customer, territory, salesperson, this is building blocks which already are microservices, which allow us to deploy them separately, allow us to scale them separately, and develop them separately. I'm not sure, am I answering your question or not?
Yeah, you asked the question, but it's a quite general
Terminology, yeah.
the microservice.
So your idea, what we physically can call a microservice, yeah? Yes, as I said, you can develop an opportunity. It could be an entity with their own database, their own development team, and functionality which belongs to this entity. So physically, it could be microservice. Yeah. There is a opinion that each microservice needs to be developed by two pizza-sized team. Usually, it's 7 plus minus 2 person, but it's not always the case. Just because this opportunity could be not so large in functionality, but need to be scaled separately from others. So in my understanding and in my opinion, one team can develop few microservices, but only in exact boundaries. I mean, one team can develop opportunity, customer, and territory, but inside of sales context. Then this opportunity, territory, and customer maybe could be separately deployed, separately scaled in case of necessity, and this will be microservice. Yep. No.
So it's domain context boundary that isolates microservices, and this is the core of the topic microservice, something that is put in small context, that models a small context.
Yeah. Yeah, and microservice, as I said, it's not sales context. It's just boundary. But opportunity, pipeline, territory, this is microservice. Hmm?
There may be many microservices that integrate and model certain.
Yeah. Many building blocks, which at the top will have a kind of aggregation layer. And in case you ask for opportunity from some other context, this call will return your opportunity with a pipeline, with a territory, with a customer, product, and salesperson inside of this object. Yeah? But this aggregation layer will aggregate responses from all other microservices. Yep. And there is an opinion that each microservice needs to be developed by two pizza-sized teams, but I suggest to not stick to this term. Just because it could be not too big service, too big piece of functionality, and set of microservices could be developed by one team, but we still have a possibility to scale them separately and deploy and deliver them separately, which is important. Another feature of microservice is a decentralizing data management, when each microservice have their own persistent layer. So we have a polyglot persistent. It's very important just because some functionality and need to have specific persistent layer. As I said, it could be a relation database when we have, and when we need some transactions and complex joins maybe, and some ACID options. But some other should not have such features, and we can just utilize NoSQL database. Maybe some database need to utilize graph database. Maybe some database are really heavy loaded and need to utilize this kind of database. Not database, I mean services. So microservice gives us polyglot persistence options. Another feature of microservices, you need to keep in mind that your service could fail at any time. And you to design this service keeping in mind this option. In case of Monolith, you can have 2 nodes, 3, 5 nodes. But in case of nodes, it's not right term. I mean, kind of containers which run this service. But in case of microservices, it could be 20, 50, hundreds of containers which run in these services. And the possibility of failure increasing a lot, in 10 times, in 20 times, and much more. So you need to be sure that in case any of container which run your microservice, any of nodes which run your microservice will not affect availability of your functionality. I will discuss and I will tell you a bit later how we can design it and how we can handle it. But this is just a placeholder for such discussion. And some key consideration regarding microservices, and again, few sentences which we need to follow developing microservices. We need to have rapid provisioning. The times when you asking some support guys to provide some new VMs and install some soft on these VMs already gone. So you will not wait few more days, maybe weeks, as some project already waited. You will need new VMs and the new machines available as much as possible. One more point is monitoring. It's not enough to have Zabbix installed somewhere. You will need to monitor every service call. You need to know how fast it responds, how much request failed, in order to organize balancing between them. And as I said, we need to apply a DevOps culture inside of team, which will develop microservice. Because, again, it's my personal opinion, if you write this code, you own this code, and you are responding about delivering this code. It's a usual question at all as a talk. I just prepared this slide just because of this. Everyone asking what's the difference between microservices and SOA. There are lots of opinion. I will not argue with anyone, but there are one of the guy, maybe you know him, Martin Fowler, who said that microservices, this is a subset of SOA. And his coworker said that this style of SOA. In my understanding, SOA it's a approach of integration of a set of applications. But microservices, it's approach of integration services inside of one application. So we are going to one level deeper. But anyway, let's stick to subset of so, and it will be okay. I'm sure you will not argue this guy. Okay, then another pattern which we need to follow developing microservices, which called API gateway. We have a Russian site, a Zone Room, with a nice book, Blood of EPAM in Russian. Okay, this question is just from the okay, anyway, let's imagine how many microservices could deliver to us this page. Can anyone try to count it? So in case we have a Monolith application and then we sliced it to microservices. 5? Yeah, something like that. But anyway, the question is, it's not real number, but anyway, we can split this page on some microservices. For example, one microservice could deliver us a basket with some values. Another microservice could deliver us a availability of our books on our goods in a warehouse. Some other microservice could deliver as a recommendation. Another microservice could deliver as a upsell options. So it all could be different microservices. And all these functionalities could be developed separately. How it works in real life. This is a usual approach, which we all use right now. Our page doing lots of calls to our backend in order to aggregate them all and compose final page, like this one, right? All these calls sometimes depends on each other. Sometimes they are waiting response from other calls just because browser has a limitation of parallel calls to one single domain. And all of them have a kind of latency, network latency, which adds some time to a final response. Then we have API or backend service, which trying to ask some other services, somewhere in a synchronous way, somewhere in, like this example, in an asynchronous way, but not all implemented. But anyway, we have lots of latency before our API, and we have lots of dependencies in the calls before the API. How API gateway solve this situation? We are splitting all these calls to a single one. For example, give me a page of book, ID 1 or hundreds. And our API ask all services behind him, almost without any latency, just because there is a private network in some data center. Knowing what kind of structure this API need to return to our UI part. And as you can see, we have only small amount of network latency here, and we have no dependency to other calls, and this gives us a bit more flexibility, and this request, of course, will be much faster than previous one. How it works under the hood? Okay. For example, we have a first step. When we got a call from some of the client, In this case, it could be some Xbox. By the way, this is a picture from Netflix tech blog. Then at the layer of JVM language runtime, we have a kind of set of routes, which routes in this request to separate aggregation layer. For example, as a picture with the sales context and support context, we can set this context as an aggregation layer. And for each calls, we can have such of aggregation layer which aggregates a response for separate clients with some specific way. So having a routes, it's like a Apache or Nginx routes. We can direct our and forward our request to this aggregation layer, which in step 6 ask, in step 5 actually, ask all available services for response and aggregate them in a one object or one entity and respond back to the client. There are some libraries already exist in the Netflix. It's called Zool, which allows us to configure these routes on the fly. All these routes are stored in step 2. Some database, which could be configured on the fly, but some operational guy. In this case, you can do lots of things. For example, you can utilize some deployment approach much efficiently. I mean, in this case, you can have a separate set of services, separate versions of services, and split requests between them as you wish. You can utilize canary deployment at it, as Netflix is doing, and after analyzing a lot, the points in all other traffic to these new services. So anyway, this works in this way. You have a layer with a routing, which known how to manage your request and known to what part of cluster you need to forward this request. Okay, maybe questions?
So you use functional reactive programming as a way to decouple the language-specific features, which are event-driven probably, to the asynchronous Java API, which gives your facade to your service.
This kind of facade for aggregations.
Yes.
Yeah. In this layer, you have some aggregations, and each aggregation have some microservices inside.
But so what's the value of FRP in this? Why did you choose to use and which library do you utilize in Java?
Excuse me?
Reactive programming, which is the...
Oh, this reactive programming here only for asynchronous calls. Yes. So it, as you understand, it will be much in case of lots of aggregation layers, from which you need to compose final response. It's much better to call them asynchronously, of course. So only for these purposes, we have a asynchronous API here and reactive model.
Which library do you choose to use? String Reactor or RX?
From my point of view, it's better to use, not better, but might choose a Netflix stack, Netflix OSS. Just because this said that is battle tested, and when you're using Netflix right now, you're already utilizing this library, this code, and this model. They covered all these patterns which we are going to discuss, by their own software, which already open source. And as I said, battle tested already, because everything work fine. Actually, lots of options, but from my understanding, it's better to use products from one stack in order to be able to maintain it easily. But of course, there is options, for example, for next part, for service discovery, lots of options. And there are, actually it's more wider topic to discussion regarding service discovery. And we have in Minsk one tech talk regarding service discovery options and available products which we can utilize for this. But anyway, we are talking about patterns now. Okay, one more patterns which we need to follow is the service discovery, how it works and what it's for, actually. There is a problem. In case of microservices, service I, service B, service C, of course they will be represented not in a single instance. It could be 10, 15, it could be lots. For example, Netflix have something about 40,000 of services, instances of services. And let's imagine all of them here. How our service, our API gateway, or our aggregation layer can find of them? All of them have different API, different port numbers. It's one of the issue. Another issue, how to load balance between them. Absolutely no clear idea. So in case of microservices, we need to introduce a service discovery block. When each service during instantiation register itself in the service discovery. In case of scaling, new versions of services will register itself in the service discovery. Or in case of scale down, they just remove this instance and after some time will be unavailable in a service discovery, service registry as well. So our client firstly asks service discovery for available instances and then load balance our request among available instances. Few words regarding implementation. Again, if I will talk about Netflix, again they have an implementation for this pattern. It's called Eureka. This service registry have a heartbeat, and during some time asking each service about availability. And each client have a local client with a database of all available services. This is as it works right now. Netflix is going to release second version of Eureka, which in a way you can subscribe to particular set of services. For example, your service using service B, but for now, your local client will get all information about service A, service C, and service B, and this is redundant and you really do not need it. But for second version, you will subscribe on changes on a service B, and your local client will have information about service B only. But it will be in the second version. I don't know when it will be released. Maybe some questions? Nope. We have some time? Some minutes. Okay. Another pattern which we need to follow could be called as shared nothing. It's a usual situation for some stateful services or even for monolith application. When it's a monolith application side, you have some session with some information. It all depends on your functionality, but in some cases, this session could contain lots of information. It's very hard to work with the flows, which still not saved in the database, but you need to be able to switch between steps, back, forward, and again. And usually, this information is saved in a session state. So let's imagine you have a load balancer with a sticky session enabled, and each request from one particular client going through this load balancer to a particular node, just because you have sticky session. And it's usual situation when this node goes down and load balancer redirected you to another node, which have no idea about your session. User can lose all information inside of session. User lose some forms, some flows information, and so on. So in case of microservices, this situation will not happen because you need to follow stateless approach. You should not save any session information inside of services, even in the thread local. So how we can handle it? We can store information in the client side. We can store information in database. We can utilize distributed session layer when we will distribute your session among available nodes in case you absolutely need it. Or we can implement absolutely stateless services. When each service takes a request, compute something, produce some response, responded to client, and without storing any information from the client. Questions?
It's like REST.
Nope. Yes, REST also said that we need to do this, but it's usual case when even REST services have session information on some layers. But under this layer, you anyway have a monolith, so your all monoliths have a state anyway.
But it's some pattern to keep the state. It should be stateless if it's REST.
Yes, but will you respond with some G-session ID if you logged somewhere and so on? But this is, yes, but everyone's doing it. Absolutely, I agree. But I faced a lot of projects which store in states. Formally it's not REST, but under the hood it's REST with a state. It's absolutely normal situation. Okay, going forward. Another pattern which we need to follow is a configuration management. There is a nice site, 12-factor apps. Does anyone heard about it? 12-factor apps manifest? Nope. I suggest to go to the site and read it, just because there are a group of people who have a lot of experience in developing cloud-native applications. They have lots of experience, and they had lots of pain in the past. And through the pain, they developed some principles which need to be followed in order to develop cloud-native applications. In our case, this is absolutely matching microservices approaches. And one of the principles which need to be followed is the externalization of configuration. And there is suggestion to, I'll talk a bit about it a bit later. What does they mean? In case you're storing your properties or configuration of your services inside of property files, and then these property files wrapped and built inside of your var on jar, then it hardly could be called as a configuration. Just because things which will not be changed could be called as code only, and things which will be changed depending on environment or situation could be called as a configuration. So property files with the hard-coded values and hard-coded destination to database, even if you hard-coded it in a production somewhere manually, cannot be called as a configuration. This is simple code. Configuration need to be configured and at any time, with any values. And that's why we have a principle of microservices that we need to move all configurations to some external locations. And all our microservices will look to this location, took this configuration, and apply to particular environment. So how it works in real life. We have some products which help us to utilize this approach. And one of them, Spring Cloud Config Server, which works in the following way. You have a config server, which looks to Git repository with properties files or some YAML files. And this Git repository gives us a lot of flexibility. There are lots of branches inside, under the hood. You can utilize versioning, of course, there. And this config server builds in configuration from repository. And all microservices, in our case, it's main application client, asking this configuration service for configuration and for particular environment. So in case our microservice will be deployed in a development environment, it asks configuration server, give me some development configuration. It's all managed by Spring profiles. In case our service will be developed to QA environment, it asks configuration for QA environment. In case of production, for production environment. This particular implementation for Spring Cloud config utilize some utility method with a refresh and restart. So in case you change your property in a runtime and deploy into production, then this property automatically refreshed in your configuration server, and then your application could hit with a refresh button, and all properties inside of application will be reloaded on a runtime in a quite transparent way. There is one more implementation from Apache which allows us to subscribe to changes in the configuration server. So even in case of changes at the configuration server, they will be pushed to our clients without any URL utilization. So this allows us to change our configuration of application of our services on a runtime and in a more faster way. Maybe some questions?
I have the following question. I haven't worked with this, so maybe a little dumb. But on every request should be reference to this configuration server, or just at some time interval? which is better. I mean, otherwise, if it's on every request, I believe it will be quite overheat.
Regarding Spring, you're creating your beans in a context with parameters from this configuration servers. And they're available inside of context all the way, all the time. But in case you need to change it, I mean the configuration, you change it there, and then hit this URL and parameters inside of your beans will be updated. So it should not be called configuration server during each request. We just push our configuration inside of bin, which is singleton, of course, in most cases, and available in the context. Got it? Okay, maybe we can do some break.